You touch it, click it, and rely on it every single day. For most of us, this is the primary bridge between our thoughts and the digital world. Have you ever stopped to wonder how this plastic, springs, and silicon actually come together? It looks simple. It's a masterclass for that final, satisfying keystroke. We're heading deep inside the production line. See how raw plastic pellets are transformed, how components become the keyboard on your desk for that final, satisfying keystroke.
It's a journey from raw material to the final, satisfying keystroke. Let's pull the switch on this process. This is how keyboards are made.
This is injection molding. We start with raw, high-grade plastic pellets. They are forced at immense pressure into molds. It takes only seconds to solidify. Every keyboard starts with the brain, the PCB. Manufacturers use surface mount technology to place tiny components. This ensures every single input is registered instantly.
The case is the foundation for the typing feel. Manufacturers reinforce shells. This ensures the keyboard doesn't flex or creak. This rigid skeleton prevents that holding a key, the board feels solid and stable.
They're brought together. This is where the foundation is finalized. By mounting the PCB securely to fit shell, the marriage of the brain and the sensitive circuitry, and the stage is set the switches.
Not all switches are born equal. A linear red switch provides a smooth, uninterrupted path. A tactile brown switch mid-travel, both tactile and audible feedback.
Inside this housing, a precision-wound metal spring sits under a stem. When you press down, that stem moves, forcing two metal contact together to close a circuit. It's a physical event that has to happen perfectly. Creating these at scale is an engineering nightmare. Imagine assembling a watch 60 times a minute. Manufacturers use fits. These machines must feed the stem and snap bending the fragile contact leaves inside. Before they touch your desk, these switches are stress tested. Some are rated for up to 100 million keystrokes, simulating years of intense gaming. This focus on consistency makes it a tool that pros trust their performance on. We use a structural plate cut with a CNC machine. The switches snap in first. Fine-tuning, like lubing, requires human eyes and hands. One detail separates a professional board: the stabilizers. They ensure that wide keys don't rattle. Fine-tuning requires human eyes and hands. One detail separates meh boards from professional ones: properly lubed and hand-tuned stabilizers. They ensure that large keys don't rattle, delivering that solid, thocky feel. Dropped onto the PCB. Permanently soldered. Sockets allow you to pull a switch out. This is the final mile of production, from raw plastic to a singular goal, to ensure that when you take it out of the box, plug it in, and hitly the engineers intended, perfect. Here, the human touch is still king. This eliminates any metallic ping. Now listen to that solid thock. This CNC plate fits perfectly. Everything is locked in. These are just plastic bits. But we use high-precision injection molding, fusing two layers together permanently. It literally won't wear off. Caps go through finishing. They're tumbled to remove any sharp sprue marks, those little nubs left from injection. Then they're inspected. Once they pass, they're pressed. The board comes to life. The board faces its final boss. Software simulates a rapid-fire typing test. High-speed cameras scan the RGB spectrum. This ensures perfect, premium quality. Each cap is tumbled, polished, to remove the tiny sprue nubs. Texture defines your typing experience. We'll have a slight, pleasant grit, ensuring every row has a consistent finish. Every board hits the QA Gauntlet. A fast matrix test checks signal stability. If a single trace is weak, that board is pulled from the line. No exceptions. In premium builds, manufacturers rely on double-shot molding. By injecting two colors in sequence, the legend becomes a permanent part. It's physically impossible for these letters to fade. Finally, it's the light test. High-speed sensors scan the PCB. Any flickering and the unit is rejected. From raw plastic to this finished instrument, that's how your keyboard is made.
A symphony of engineering, material science, and automation, all to make sure you're typing as smooth as possible. Which part of the process surprised you the most? Let me know in the comments, and don't forget to like and subscribe for more deep